So basically RAID level 0 is used when data safety is not important. So example, data can be recovered quickly from other resources, because in RAID level 0, as we discussed, okay, it's non-redundant data. We are not repeating the data. We are just stripping the data for the sake of parallelism. Level 4, never used since it is subsumed by 5. Already it has been improved version of level 5 is there. So no use of 3, 2 and 4. Level 6 is rarely used since level 1 and 5 offer adequately safety for almost all applications that we discussed when we were discussing about 5 and 6. So competition is between 1 and 5. Okay, so you have to think, if you do not want repetition, your data is not very critical, then you can go for stripping, but it will give you parallelism. Whereas 5 will give you parallelism, but also repetition of data, so you need to have high memory capacity. So level 1 provides much better write performance than level 5. Level 5 requires at least 2 block reads and 2 block writes to write the single block, because you have to think that there is a parity bit, okay, involved, which is not there in level 1. Whereas level 1 only requires 2 block writes. So that 2 extra blocks is for parity each. So level 1 preferred for high update environments such as log disk. Level 1 had higher storage costs than level 5. Disk drive capacities increase rapidly, whereas disk access times have decreased much less. I/O requirements have increased greatly, example for the web servers. When enough disks have been bought to satisfy required rate of input-output, they often have spare storage capacity. So hence, it is often no extra monetary cost for level 1. Level 5 is preferred for applications with low update rate, okay, rather. And level 1 is preferred for all applications. So a database file is partitioned into fixed length storage units called blocks, and blocks are units of both storage allocation and data transfer. So it is contiguous memory of the sectors in terms of physical storage. Okay, so we have a buffer. So buffer portion of the main memory available to store copies of the disk blocks. And who does all these allocation, deallocation? The buffer manager. Okay, it manages and allocates the buffer space in the main memory. So this is how this is all managed. So in operating system, there is a special memory assigned, and there is another functioning controller, okay, who has the authority and the responsibility to manage that. So basically, buffer manager is going to see whether the block is already there in the buffer. Okay, if it is there, then it will return the address of the block in the main memory. If it is not there, then it will allocate the space. And for allocating the space, it has to see that if there is a space in the main memory. If it is not there, then it has to replace by some another block. So probably there are another strategies that which block should be replaced. Okay, so these are the replacement policies. So replacement policies is least recently used strategy. So if there is a block of data in the main memory which has not been used for a long time, that means it has a we can assume that in future also it is not going to be used. So better you should replace this block by the block which is now currently to be used, and it doesn't have space in the main memory. Okay, so idea behind LRU is to use past pattern of block references as a predictor of the future references. So there are other strategies as well, that is pinned block. So in WhatsApp, you have a feature that some groups you can have maximum 3 groups which you can pin. That means they go on the highest priority. So memory block that is not allowed to be written back to the disk. Why? Because these are very, very important. It cannot be replaced. So toss immediate strategy, that means it frees the space occupied by a block. It frees the space occupied by a block as soon as the final tuple of that block has been processed. So once the task is over, it frees the space, right? And most recently used strategy, system must pin the block currently being processed. After the final tuple of that block has been processed, the block is unpinned. That is, it becomes the most recently used block that we are already using in our WhatsApp app in our daily life. So buffer manager can use statistical information regarding the probability that a request will reference a particular relation. So example, the data dictionary is frequently accessed. Heuristic, keep data dictionary blocks in main memory. So the, for example, if there is a book of 200 pages and there is an index of say 5 pages. So the index will be always there in the main memory and should not be replaced. Why? Because to access any block, always what we refer the index. So why to waste time on the read and write operation from the main memory to the disk and vice versa for the index pages. Okay, similarly, data dictionary. What is data dictionary in DBMS? We have seen in our previous lectures, initial lectures. Data dictionary is metadata. That means it is storing data about data. So whenever you want to deal with our database, obviously data dictionary will be something which will be used every second. So that's why it should not be replaced and should be there in the main memory buffer. Okay, buffer we discussed. There is a memory specially buffer, which is a portion of memory available to store copies of the data blocks. So file organization in continuation, the database is stored as a collection of files that we said earlier. Each file is a sequence of records and a record is a sequence of fields. So in SQL language, okay, you create a database, you create tables, okay, and in each table you have attributes and every table will also have rows. So rows are the records, attributes are the columns. Ultimately that data, multiple tables, you can refer it as a file or maybe a file as a table and combination of related files or say tables as a database. So one approach is assume record size is fixed. Each file has records of one particular type only. Different files are used for different relations. So if you have whatever we have learned in our DBMS through relational database system, through SQL, DDL, DML, DCL operations, we know that our record size is fixed and each file has a particular type only. Okay, if we say that this attribute is of character or varchar in terms of Oracle or SQL Server, or it is a numeric, okay, we describe that as a particular type. Relations can be shown by primary key, foreign key, okay, so that we can know which is the parent table, which is the child table, which is the candidate key, which is the super key, and all that. So these are the fixed length records as discussed earlier. So record 1, if say this is of 4 bytes, this is of 4 bytes, this is of 2 bytes. So 4 plus 4 plus 2, 10 bytes. So second record will also take 10 bytes. So it will have a fixed length records. So free list, store the address of the first deleted record in the file header. Why? Because the moment it is freed, it should be stored so that next record will be replaced over here since this portion is now free. Okay, so this can be done with the help of linked list. So in data structure lectures, there is a dynamic mechanism to store records through our data structure called linked list. So if we have, this is one linked list node where this is one attribute of this linked list, second attribute, third attribute. So this is one node. This is having the pointer, the last attribute is the pointer. So this is data and this is pointer. And now pointer is now pointing to the next record, which is free. So this, if you can see, then this is that the next, this field is free. You can store it over here. You can store it over here. You can store it over here. So if suppose, if you would have stored 4 records in an array, character array, or maybe a structure, then probably this would have been not possible because we do not have contiguous 4 memory blocks for storing records. But if you have linked list concept, then definitely using linked list, you can see the free spaces and you can allocate the 4 records and you will not even lose the track of the sequence of the records because the pointer to the next location also can be stored using linked list. Now this was the fixed length records and next is the variable length records. So variable length record arise in database in several ways. So you have to store multiple record types in a file. So in C++ or C, it can be done with the help of class, which is an encapsulation of data members in data functions. If you use C, then we have structures, which is a heterogeneous combination of different data types. Okay, so they are ultimately different record types rather. So, but structure is also different data types, but ultimately one record type will have a fixed length. So if you want to have multiple record types, then you have to go from C to C++ and use classes for that. So record types that allow variable length from one to more fields. When we have learned advanced SQL queries, okay, at that time we had learned how to allow variable lengths. For example, varchar and varchar2. These are used for variable lengths. And there is another type called as char. So what is the difference between char and varchar? If you say char of 10, 10 bytes are allocated. But if you enter a name, say Amit. So Amit name requires 4 characters. But still it will occupy all the 10 bytes and 6 bytes are wasted. But in terms of varchar, it is dynamic memory allocation with the help of linked list. If only Amit is typed, only 4 memory will be used. Even if you say varchar of 10, okay, only 4 will be used, 6 would be released for some another job. Okay, that is the way how fixed and variable can be used in terms of data types. So record types that allow repeating fields used in some older data models. Now, you know, you can repeat the structure type. Even you can use inheritance in terms of C++ to duplicate a particular object. Okay, even we have learned in relational algebra how we can rename and form another copy so that a same table can be referred twice. So this is how we can implement the repeated fields. So there is a slotted page structure shown over here where we have got a block header. So this is a block, and block is a combination of records. So in the block header, you will have the information, how many entries are there, you know, where is the free space, when the records will start, what is the first record, what is the second record. So this is the entire structure. So slotted page header contains number of record entries, end of the free space in the block, location and size of each block. Because if you know the location and size of each block, you know, you can include variable type of sizes of records. So if I say the first record is of 10 bytes, so if I know the starting and the end, or even if I know the starting and I know that this is of 10, we can say that the next record will start at, say, 10th location, right? Suppose second record is of 20 bytes. So if second record is starting at, say, 10th address and it is having 20 bytes, so obviously the third record will start at 30th location likewise. So even if you know the location and the size of the each record, you can track the another record. So records can be moved from around within a page to keep them contiguous with no empty space between them. Entry in the header must be updated. So pointers should not point directly to the record. Instead, they should point to the entry of the record in the header. So as in linked list, if you know the first address of the record and suppose it is of fixed length, you can automatically track all the records because first record stores the pointer to the next record. So if it is an array, it can be accessed fixed length just if you know the starting address. But if it is dynamic memory allocation, and even if you are using implementing through linked list, and even if you know just the starting address, you can track the another record with the help of pointer. Because in linked list, the pointer of the first node will point to the second node. The pointer of the second node will point to the third node, likewise. So even every node is of variable length, still you can track with the help of linked list using dynamic memory allocation if you know even the starting address. So the organization of records in files, they are using various techniques. First is the heap. Heap is nothing but a record can be placed anywhere in the file. Sequential, it stores record in the sequential file. Hashing, a hash function is computed on some attribute on each record. Now this we have discussed in our data structure. Okay, and in the lecture of B plus trees, again, we will go through this point of hashing. So hash is a function we need to define, okay, computed by some attribute. Now, for example, we are storing names. So names starting with A are almost more than the name starting with Z. This is from our personal experience, which we have saw. So if you use the fixed length record, then probably it will be injustice with the name starting with A block, because it will overflow and it will not have space. Whereas the name starting with Z, that block will remain occupied because it will have very less inquiries. So in such terms, in such cases, you need to define some function, okay, and that is called as a hash function, which where the result is specifies in which block of the file the record should be placed depending upon the calculation of the function. Okay, so records of each relation may be stored in separate files in a multi-stable clustering file organization. So there is a clustering file, okay, that is called as multi-table, because multi-table means table pointing to another table. So your linked list can be achieved where a node is nothing but a table, right? And the collection of tables, they are called a cluster because they are of similar types. Records of different relations can be stored in the same file with the help of this type of organization. If you study data mining, their clustering and clustering algorithms are defined more clearly. You just have to note over here is that in clustering data mining algorithms, instead of node, it will be our tables as the relation. So the motivation here is that you can store related records on the same block to minimize the input-output I/O. That is the basic purpose why we studied these different types of organizations of records to be stored in files. So multi-table clustering file organization. Over here, if you can see, stored several relations. Now see, only 5 slides are remaining, but I would request that I would continue this topic tomorrow. What I will do, I will revise the previous topics again in 10 minutes, all the RAID levels, and then I will start from these 2-3 slides before, that is from this slide number 25 and continue till slide number 41. So this way we will even revise and continue this in our next lecture, so that even you will have the time to revise whatever has been taught today, because it's going too much lengthy. But then this will end our entire 1 unit on storage structure and RAID. Okay, thank you very much for the patience listening. I'll end the meeting, and